Okay, welcome once again to another interesting and fantastic video now on Brainwaves Academy online tutorials. Today we're going to be discussing quickly how to use the Crammers Rule to solve a system of simultaneous equation. Remember, you recall we are talking about the inverse of a matrix in our previous class, if you can recall. So the inverse of a matrix actually allows us to also solve the simultaneous equation in a very simple fashion, because we have talked about when you multiply a matrix with its inverse, you're going to get the identity matrix, right? So basically, it's very straightforward. I have a matrix A. If I should multiply it by the inverse, is the same thing as having that same matrix, then multiplying by the inverse. So I'm going to automatically get the identity matrix, which is just I. Fantastic. So right now, we are going to be now talking about how to use it in solving system of equation. Remember, if I have a matrix in the form, let's say 3x plus 4y is equal to 5, and I have another one, x plus 2y is equal to, let's say, 2. We can break down into the matrix of the coefficient, multiplying this particular variable, and then this is the matrix of constant. You remember, this is going to be a matrix of coefficient. We have 3, we have 4, we have 1 and 2, right? So we have this matrix, which are the variables. We have x and y. Then this is going to give us the matrix of this constant, which is 5 and 2. So if I represent this matrix as matrix A, this is going to be my matrix of the variables, matrix X. Then this is going to be my matrix of constant. I can call it matrix, let's say B. Now, automatically, if I want to get X, now using this idea, I'm just going to multiply this A, matrix A, with the inverse. So if I multiply it over here, right? If I multiply it over here, I'm going to do likewise to this part. So I have matrix A inverse B. Now, this particular matrix is going to give me the identity matrix. Now, this is going to be A inverse B. Now, remember that the identity matrix multiplying any matrix at all is going to be that matrix. So the matrix of the coefficient here is going to be just A inverse multiplied by B. So let's get A inverse from here, then I will solve it. A inverse from here, this is my matrix A, right? All I need to do is to first of all get the determinant, then I will now inverse this particular matrix. Is that also? So let me not do it over here, let me do it over here. Now, see, our matrix A right now is what? Is just A is 3, 4, 1, and 2. Then our A inverse is automatically going to be, our A inverse is just going to be what? 1 over determinant. Determinant of this should give us 3 multiplied by, this should be 3 multiplied by 2, right? Then minus 4 multiplied by 1. Is that also? So we have 3 multiplied by 2, then into, I will interchange the diagonals. I have 2 and 3, then negate the other 2. So I negate this and this. Now this automatically become our inverse. So this is 1 all over, we have 6 here minus 4 into 2 minus 4 minus 1, and then we have 3 over here. Fantastic. So this is just 1 all over 2 into 2 minus 4 minus 1 and 3. This automatically become the inverse, which we can take into consideration. If we take it inside, we'll have 2 divided by 2 is 2, 4 divided by 2 is minus 2. This is actually 1, right? Because 2 divided by 2 is 1. Then we have minus 1 all over 2. Then we have 3 all over 2. Is that not fantastic? So if I want to use it to just solve, if I take this A inverse over here, I multiply it to this part over here, I'm going to get the identity matrix, which is just going to give me X. So if I multiply this A inverse and B, I'm going to get this coefficient matrix. So let's try it over here and see. I have A inverse multiplying B. This should give me my X. So let's try it. We have 1, we have 2, minus 1 all over 2. We have 3 all over 2. So all I need to do, I'm multiplying it by the coefficient, by the constant matrix, which is just 5 and 2, multiplying it by this, then I will get my matrix of the variable, which is X and Y. So this multiplied by this is 1 multiplied by 5 plus this multiplied by this, which is just 2 multiplied by 2, right? 1 multiplied by 5, 2 multiplied by 2. Then similarly, to get the other term that is supposed to be here, I will do, that's the first row and the element in the second column, right? So I have, this is negative, this is negative, pardon, this is negative. So this should be minus 4, minus 4. Is that also? Because from what we have gotten, this is negative. So we have 1 multiplied by 5, that one is accurate. Then this multiplied by this is plus, but this is negative, negative 2 multiplied by this. Fantastic. So the other one is going to be minus 1 all over 2 multiplied by 5. So we have minus 1 all over 2 multiplying 5, then plus what? Plus 3 multiplied by 2 over 2. Now this is going to be, this is 5 minus 4. While over here I'm going to be getting minus 5 over 2. Then this particular guy here is going to give me plus 3, right? So this automatically, this should give me 1. This should give me 1 over here. This is 1. Then here, I'm going to take the LCM here is 2. So I have minus 5 because 2 into 2 is 1 multiplied by 5 is 5. Then the negative. Then here, you know, this is like over 1. So 1 over 1 into 2 times, go 2 times multiplied by 3, that is 6. So that's how I will get my values to be what? To be 1. And the second one here, minus 5, that's 1 all over 2. Now this corresponds to my X. So therefore, my X here is 1 and my Y here is 2. That is the concept of what? Of the inverse matrix. So if I want to use the well-known, which we call the Crammers Rule, I can also do it in this way. I have my matrix of coefficient, which is what? 3, 4, 1, and 2, right? So let me get the determinant of this matrix. So this can be called change in A, or you just get the determinant of this matrix A. Determinant of this matrix A should be what? 3 multiplied by 2 minus 4 multiplied by 1. Is that also? We have 6 minus 4, which is just 2. Good. So to get the variable for X, to get the variable X, right? I'm going to take this particular constant matrix and replace it here. I'm going to replace it here. So instead of 3, 1, I'm going to have 5, 2, then 4, 2, right? To get this variable X, I will divide it by the determinant of 3, 4, 1, 2, right? So I'm going to divide the determinant by this other determinant. I'm going to get this matrix X. Good. So here, what am I going to get? I'm going to get 5 multiplied by 2 minus 4 multiplied by 2. And of course, this determinant over here, we have gotten it here, which is just 2. So here I'm going to get, this should give me 10 minus 8 upon 2, right? This is the same thing as what? 10 minus 8, it is 2 over 2, which is just 1. Now, to get the other variable y, I'm going to take this particular constant and replace this particular column for y. So I'm going to get 3, 1. Then instead of 4 and 2, I'm going to take the constant and replace over there. So I have 5 and 2, right? So similarly, I'm going to divide it by the same coefficient matrix, which is 1 and 2. The determinant here, I've gotten it, which is 2. So the denominator is just 2. Then here, 3 multiplied by, I'm going to do 3 multiplied by 2, determinant of the numerator. Then this is 5 multiplied by 1. So 3 multiplied by 2, this should give me 6. 5 multiplied by 1 should give me 5 over 2. 5 minus 1, this is just 1 all over 2. So you can see this method actually tallies with this particular method also, right? So this is great. This is fantastic. So let's do one more example, and then we are going to call it a day on Crammers Rule. So for example, if I have this matrix, say 3x minus 2y and is equal to 5, and the second one is minus x plus 4y, and this is equal to 2. Now, my coefficient matrix A, let me call it matrix A, is going to be 3 minus 2, then we have minus 1, and we have 4. Fantastic. So let's go straight to get the determinant of A. So determinant here is going to be 12 minus this multiplied by this is minus 2, so which is just 10. Now, to get my x, is very straightforward. I'm going to take the constant here, replace it here. So I have 5, 2, minus 3, and then 4. And I'm going to divide it by the coefficient matrix, which we have gotten the determinant over here as what? 10. So here is just 10. This should give us 20. This and this is 20 minus into 2 multiplied by 3 is 6. There's negative, so we have negative 6. So this is 20. This and this should give us, right? Is it 26? Is it 26? Let's look at it. This multiplied by this is 20. This multiplied by this is 6. Right? Oh, no. This is minus 2. Pardon, this is negative 2. Right? From here, this is negative 2. So this should give us negative 4. Good. So this should give us 24 over 10, which is the same thing as 12 all over 5. And it's the same thing as, let's say, 2 times, it will enter 10. 5 will go into 12. 2 times, it will remain 2 upon 5. So 2 whole number, 2 over 5. Fantastic. So now to get y is the same thing as taking this particular column to replace the column for y. So we have minus 3. We have, it's not minus 3, pardon. It's not minus 3, it's 3. So this is 3, but here is negative 1. 3, negative 1. Instead of y, I'll put 5 and 2. Then what I have in the denominator will be 3 minus 2 minus 1 and 4. And that determinant, we have already obtained that as 10, which is here. So this and this will give us 6. This multiplied this 6. Then this minus this multiplied by this is going to be minus 5. So this is 11 all over 10. And similarly, this is just one whole number, 1 all over 10, right? 1 all over 10. So that is straightforward. Now, can I use the concept of inverse of matrix to do this? And even if it is 3 by 3, I'm going to do likewise. But let's see, can I use A inverse B to be able to get that coefficient, which is x? So how can I get A inverse from here? So A inverse is just going to be 1 over the determinant of A, right? Then multiplying, I will interchange this, and negate this. So if I negate this, is minus 2, right? So we have minus 1. So if I should do that, my determinant is 10. So this is 1 all over 10 into, we have 4, 2, 1, and then 3, right? So my A inverse is just technically going to be what? 4 over 10. So we have 4 over 10 over 10. So here we have 2 over 10. Let me extend this. So we have 1 over 10. Then we have 3 over 10, right? So I'm going to bring it down here. So we have 4 over 10. 4 over 10. We have 1 all over 10. We have 2 over 10. We have 3 over 10. Now let's multiply this with our constant matrix, which is what? Which is 5 and 2, right? 5 and 2 over here. So if we multiply this correct, we are going to have 4 over 10 multiplied by 5. So we have 4 over 10 multiplied by 5 plus 2 over 10 multiplied by 2. 2 over 10 multiplying 2. So similarly, we're going to have 1 over 5, 1 over 10 multiplying 5. Then lastly, plus 3 over 10 multiplying 2 over here, right? So this can go into this 2 times. This can go into this, can go 1, this 5. So I'm left with, over here, I'm left with 4 over 2, and this can go into this 2 times, right? So here I'm just left with 2. 2 plus 2 plus 2 all over 5. Is that correct? 2 plus 2 all over 5. Then here I'm left with 2, here 1, so 1 all over 2. This will go 1, then 5. So here I have plus 3 all over 5. So this will give me, we have 5 in the denominator. So 1 into this 5. So we have 1 into 5 should go how many times? 5 times 5 multiplied by 5 should give me, what is it? Was it 10? Plus 5 into 5 is 1 multiplied by this, that's 2. So we'll have here also the LCM here should be 10. 2 into 10 should be 5. Then plus 5 into 10 is 2. 2 multiplied by 3 should give us 6. So you see here, we also have 12 over 5, while here we have 11 over 10. You see, basically, it's the same result over here. We can break this down to 2 over 2 over 5. Similarly, here is 1 all over 10. So if you have gotten any value from this video, if you have seen any interesting fact in this video, you can give this video a like and put down your comment below in the comment section. Then lastly, maybe in the next video, I'll probably give you all the type of matrices that we have, or you can check the previous video. Now, remember, if the determinant of the matrix is 0, then you cannot have the inverse, right? So if you have the determinant of any matrix to be equal to 0, then that matrix is said to be what? Singular. So that matrix is said to be singular. Thanks for watching this video. See you in the next video.